The recording. Right, the first question is calculate the de Broglie wavelength of an electron. Calculate the de Broglie wavelength of an electron moving at 1% speed of light. Speed of light. ME equals 9.1 into 10 to the power minus 31 kilograms. H Planck constant equals 6.63 into 10 to the power minus 34. Units are given. Right, give it a try. If you have done, you can share your answer via the chat. එම සිකුරාදාම රෑ වෙනකන් ගණන් හදනවා 10 ඉඳලා ඕනම කෙනෙකුට ජොයින් වෙන්න පුළුවන්. ඔයාලා තියරි කරලා තියෙන කොටස කවර් වෙනකන් මම ගණන් හදනවා. තියරි කරන්න එතකොට මම මේ පාර්ට් එකත් මම එඩ් කරන්නම්. Right. I think you are doing this question. කරලා ඉවර නම් share the answer via chat or you can unmute yourself. If there are any questions, you can ask also, right? You can ask any questions. So calculate the de Broglie wavelength of an electron moving at 1% speed of light. This is a straightforward question. These type of questions may be asked in an MCQ questions, right? ගොඩක් වෙලාවට MCQ questions වලදී තමයි වහන්නේ, not in the structured question. So straightforward, one equation is there. So I hope everybody can remember this one. The equation is lambda, this is de Broglie wavelength, equals h divided by m nu. Right. So mu is the speed, m is the mass, h is the Planck constant, and lambda is the de Broglie wavelength. Okay. So we can substitute the values like this. Speed of light is 3 into 10 to the power 8, m is minus 1, and 1%. The electron is moving at 1%, right? So nu is 3 into 10 to the power 8 into 1%, that is 0.01. So 3 into 10 to the power 6, m is minus 1, right? So m should be in kilograms because h is given in kilograms. Here, this one. H is given in kilograms, so therefore m should be in kilograms, and luckily the value is given in kilograms as well. Yes, your answer is correct. Yes, your answer is correct. Very good. So m is 9.1 into 10 to the power minus 31 kilograms. H is given. So this is a direct question. What I think. Make it out. Trick you have to remember the equation, right? Lambda equals h divided by m nu. So h is 6.63 into 10 to the power minus 34 divided by h. M is 9.1 into 10 to the power minus 31 kilogram into nu is 3 into 10 to the power 6. So you do the math and you will get the answer. මට මේ වගේ ෆයිනල් ආන්සර් නම් අනිවාර්යෙන් ඔයාලා ගන්න ඕන. මෙතනින් the chemical chemistry part is over. Now after that, the basic maths, all well maths, the calculations, right? Because getting the final answer is very important. 5 marks is allocated out of 150 if it is an essay type. And obviously for MCQs, you have to get the final answer to get that full mark, right? So the answer, if you do the calculation here, it should be 2.43 into 10 to the power minus 10 meters. Yes, both of your answers are correct. Very good. So like that, you should be doing this question and get the final answer. Yes, yes. So that is correct. All of you have done the answers. Yes, answers are also correct. Very good. Right. So this is how you do the question. It's a direct, straightforward, very simple question. එන්නත් පුළුවන් නොවෙන්නත් පුළුවන් දන්න ඒ වුණාට equation එක මතක තියාගන්න ඕන. Right? Okay, the next question. The next one. The enthalpies of the following reactions are, the second question, the enthalpies of the following reactions are shown along with shown along with. So these are the equations actually. Half H2 gas plus half O2 gas, OH gas. So delta H is equal to 42.9 kilojoules per mole. This is 42. My handwriting is a bit messy. H2 gas converts into 2H gas. Delta H is equal to 435.89 kilojoules per mole. O2 gas converts into 2O. Delta H is equal to 495.05 kilojoules per mole. Okay. Calculate bond energy of OH bond. Calculate the bond energy of OH bond for the hydroxyl radical. For the hydroxyl radical. හරි. හදන්න බලන්න. You can use a Hess cycle, right? I need you to do this one by using Hess cycle, okay? Hess cycle එකකින් හදන්න. Then we can discuss. There is one answer. Okay, let's see. Um, yes, your answer is almost correct, but small with a small deviation. Is it plus or negative, Buddha? Check that part as well. How about others? Okay, let's do this question. I'm going to do this one by using a H cycle. This is, I think you have done questions on H cycles. So When you are drawing Hess cycle, no, Puta, this is, I think it's not the answer. So, okay, let's see. Let's see. Yeah, good try. Now, when you are drawing Hess cycle, select the longest equation with the highest number of atoms and highest number of components, right? So select that one first and write it horizontally, right? So for this one, this is the highest equation, or the equation which has the highest number of components, and everything is contained within this equation. And write the equation for which has been asked as well, the questionable equation as well. The questionable equation is the bond dissociation enthalpy of OH hydroxyl, right? Hydroxyl radical. So this is what has been asked. Right? Delta H is how much? Now I'll be using the yellow highlighted equation, right? Half H2 gas plus half O2 gas, OH gas. And I'll noting down this one. This is plus 42.09. Units are not necessary if it can, but you have to make sure that all the values are in the same type of units. We can save in that way. Now, if you can check this one, and this one, all in atoms gaseous state. Atoms gaseous state. So I will write these, the gaseous state ones in here. Hydrogen gas plus oxygen gas. by using the Hess cycle, right? Because it's obvious, right? So here, this one is H2 converts into hydrogen. This is O2 converts into oxygen, and this is OH converts into ONH. So again, them pair on a cycle, right? So I will break all the bonds downwards like this. I will break this bond. So which means this is this equation, but exactly half of it, right? Exactly half of the equation which is given. Half right? In the Hess cycle. So therefore, this will be half into 435.89. Then I will go to this one. This is also exactly the half of this one, the second equation, half of second equation. And therefore, this will be half into 495.05. We have been asked about this one, right? OH bond. We have been asked about this one. If you closely check, this is OH bond and it is creating hydrogen and oxygen. Okay, this is this one. It has been asked, right? So this will be delta H. It has been asked. So let's apply Hess cycle, sorry, Hess law. Hess law. So let me clear this one, clear the dirty data here, this one. So I will be applying Hess cycle to this direction, right? You can apply anyway, so I will apply clockwise. Then it will be plus the opposite directions on negative. So this will be basically 42.09 plus delta H equals, not equals, very sorry, minus this one positive This one positive because in the moving direction, and these two are negative, right? So negative half 4 half into 435.89 minus half into 495.05, which is equal to 0. Then you can do the math and get the answer for delta H. All right. So this is not that much hard, but designing the question is the most important thing. Here the answer is 423.38 plus kilojoules per mole if you do the math. I'm not going to take the final answer. Make a දෙකෙන් බෙදලා මේක ටික් කරගන්න පුළුවන් වෙනවා. Right? I think. Any questions on this one? Any unclear points? You can type in the chat or you can unmute yourself and ask the questions. Or any challenges for my answer? You can challenge me. ඕන වෙලාවක මට challenge කරන්න පුළුවන්. මේක වැරදිද වැරදි කියන හදු විදිහ. According to your gut feeling, that's okay. There was one student of mine in 2020 batch. He's from Goal online class. He's asking a lot of questions. He's always challenging me and he has always a different way to do the question. Now he's in Canada. He went to University of Marottua, then he migrated. So if you have any questions, you can ask me. That's fine. That's okay. I hope this is clear for everybody. Yeah, I'm going to take this down and get the final answer. So I haven't done the calculation part. So you have, it's up to you to do the calculation part, okay? What does this mean by this positive value, Pata? This positive one, this one. What does it mean? Positive means it's an endothermic reaction, right? Not an exothermic reaction. Endothermic reactions means it absorbs energy. So absorbing energy means reactants are having lower energy than the products because products are created by absorbing the energy, which means the products are having high energy. High energy, what is the meaning of an high energy? Higher the energy, lower the stability. This is very important in organic chemistry, right? So when you have a kind of a reaction which has positive, the delta H is positive, it indicates that the products are having higher energy. It has absorbed energy. Absorbing energy means the products are having higher energy. Products are having higher energy means they are unstable. So instability creates unstable products. Therefore, they tends to do the backward reaction. I think you have learned that if the forward reaction, for an example, this one, this is what we have learned now. No? OH dissociation creates O gas plus H gas, right? So this direction, bond enthalpy, bond dissociation enthalpy is plus 423.38 kilojoules per mole. Now, according to the Laplace law in maths as well, in physics also Laplace is there. According to the Laplace law, what he is saying is the backward reaction will be the same value, but with different or opposite sign. Same value. So the backward reaction is the same thing, but with a different value. It's an exothermic reaction. So exothermic reaction means it is not absorption, it is releasing energy to the medium. Releasing energy to the medium means the products are having lower energy compared to the reactants. So they are stable. So that's why I said if a forward reaction is endothermic reaction, then the backward reaction, the opposite direction one will be an exothermic reaction. Exothermic reaction products are stable. Higher the energy released to the medium, lower the energy that they are having, or the products are having, then the higher stable products will be created. So that is the idea, right? Make okay, right. Then number 3, third question. Write on this question. මේක ලියාගන්න බැරුණාද ලියාගත්තද කොහොමද මම හිතනවා ලියාගන්න ඉතින් කියලා කට්ටිය right. Next question, number 3. Consider below system. Consider below system. Then draw this diagram actually. There is a trap here. This is H2. This is helium. 1.5 cubic meters. This volume. Temperature is 87 centimeters and pressure is 0.9 into 10 to the power 5 pascals. This is 5 pascals. This is volume 5 cubic meters. Sorry, 5 cubic meters, not centimeters. මම මේක මේ පරිමාණයකට නෙමෙයි ස්කේල් එකකට නෙමෙයි ඇදලා තියන්නේ. 5 cubic meters. Temperature is 27 degrees Celsius. Pressure is 1.2 into 10 to the power 5 pascals. Then I'm going to do this one. Helium pressure is put 0.9. 0.9, huh? Not 8.9, 0.9. 0.9 into 10 to the power 5 pascals. 10 to the power 5. And H2 is pressure 1.2 into 10 to the power 5. Both are in 10 to the power 5 range. Okay. First question. Tap between the two containers. Tap between the two containers is opened. Tap between the two containers is opened. And temperature was set to, temperature was set to 47 degrees Celsius. 47 degrees Celsius. Find the total pressure of the system. Find the total pressure of the system. ගාන දේශී තව ගානක් මේ තියෙනවා මම ඒක දැනට කරන්නේ නැහැ. ඒ කියන්නේ තව කොටසක් මේ ගාන තියෙනවා. I will not do that for the moment, but give it a try for this one. This is very easy. ചെറുകളിലൊക്കെ പിന്നാണ് ചെയ്യേണ്ടത്. Oh, just drop the answer. Right. Oh, yeah, that's a good try. That's the answer. I don't have the final answer. I think your answer is almost correct. Mm. Okay, good. நீங்க ரொம்ப popular Hari. Lagan. Okay. I think your answer kind of deviated, but however, let's see. Yeah. I'm just guessing the answer. Like I'm also not, I also can't remember the answer, but I also need to do this one. I will show you how to do this one, right? So this is status one, but you can see, and status two is we are removing the tap in between the two containers. Then we will have something like this. Then actually the hydrogen and helium is mixed together and it is taking the total volume of the system, right? So if you take hydrogen, right? Now, if I take volume, temperature, and pressure, number of moles, right? So these are the things that we need to consider. Now, if you take a gas, uh, the gas status can be explained by using P pressure, V volume, T temperature, and number of moles. R comes into play with the PV equals nRT. So remember, T is always in the kelvins, right? So in this scenario, the status 2, now the volume is the total volume, right? Because it is taking the total volume after opening the tap, right? So this will be 6.5 cubic meters. Temperature is 47. Pressure that we need to find, we don't know. Number of moles will be the same. Number of moles will not be changed because that is not going out, right? Okay. Then if you take helium also taking the same volume, right? 6.5. Temperature is also 47 because the total system, and pressure we don't know what we need to find. Number of moles will be the same as helium as the previous, right? So this is the change. Now, if the number of moles is not changing, right? Number of moles is a constant, and we can consider the gases separately, because even though the second status gases are mixed, we can consider the gases separately, right? So how we consider separately? The first occasion, pressure, volume, temperature will be changing for hydrogen and also for helium. So let's apply the combined gas law. P1 V1 divided by T1 equals P2 V2 divided by T2 for hydrogen and helium. Then you can take the pressure of hydrogen at the status 2, pressure of helium at the status 2. Summation of those two will be the total pressure. Right? So we will apply by applying P1 V1 divided by T1 equals P2 V2 divided by T2. Why we can apply this one is the number of moles is not changing because there is no leak for this one to hydrogen. So the P1 will be this one. This is P1 for hydrogen. That is 1.2 into 10 to the power 5 pascals. You need to make sure the total, the units are same for the both directions, right? So the volume initially status 1, that is 5 cubic meters divided by temperature T1, that is 27 degrees Celsius. It has to be kelvins because always gaseous questions are dealing with the kelvins. So this is 300. 27 plus 273. I'll remove 1.15. I will eliminate that part, right? So this is in Kelvin equals P2. This is what we are going to find, right? Oops. P2 into V2. V2 is now 6.5 cubic meters divided by T2 is 47. 47 means 320 Kelvin. Right? Now you can find P2 You do the method. This is for hydrogen. Okay. So this will be in pascals. Then I'm applying same thing. P1 V1 divided by T1 equals P2 V2 divided by T2 to helium. Then helium, the initial pressure is 0.9 into 10 to the power 5 pascals, divide into volume here, that is 1.5 cubic meters for helium. It is very clear, right? Divide by temperature, that is 87. So 87 means 360, right? Kelvin equals P2 that we are going to find. V2 6.5 cubic meters divided by T2, that is also 320 Kelvin. So you will have, this is P2 helium. You will have some answer, right? So initially this one is P2 hydrogen. You can add these two to get the total pressure of the system at 47 degrees Celsius, right? So therefore, P total will be equal to P2 hydrogen plus P2 helium. Both can be found. Then you can add these two to get the final answer. So this should be in 10 to the power 5 range. You should do the calculation. I will leave it to you. ඔයාලා මේ ගාන හදන්න ඕන. කම්මැලිකමට ඉන්න නම් එපා. You have to get the final answer. I think this is 6.5, 1.1, 360. You may do the math. I'm also not sure about the answer. Making ගන්න පුළුවන්. Right. Any questions on this one? I think no. Right. කාටට කියන්න පුළුවන්ද ඒ අපි මේ can P1 V1 divided by T1. Why we have not used PV equals nRT for this one, for each equation, for each gas. And the other thing is why we have not used combined why we have not considered hydrogen and helium combined as a combined gas. Why we have not considered that part? The reason is hydrogen is in a separate status, in status 1, or separate volume, separate temperature, and helium is in a separate pressure and separate temperature, and also in separate volume. So therefore you can't combine these two in these two status. But second status, you can consider the hydrogen and helium as a combined one. But with the connect කරන්න ඕන නිසා you have to consider them separately and calculate the pressure separately according to the Dalton's partial pressure law. You can get the summation to get the final total pressure. Okay. විනාඩි දෙක තුනක් දෙන්න ලියාගන්න ටක් ගාලා. හරි. හිතන මේක හදාගන්න නැති කියලා. ඊට පස්සේ අපි ඊළඟ ගන්නට යනවා. right. මම ඊට පස්සේ ගන්නම් අපේ මේ තියරි ක්ලාස් එකේ ටියුට් එකේ ගානක් එනර්ජිටික්ස් වල. මම ටියුට් එක පොඩ්ඩක් ෂෙයා කරන්න. මේක මේක මේ ටෝටල් අපේ ටියුට් එකේම තියෙන ගානක් මම ගත්තේ. මේක මේ පස්වෙනි ගාන හදන්න බලන්න. try fifth question. This question. What you can see in the screen. If you want, you can copy down the question, or just you can just try with the answers. I will give you like around 10 to 15 minutes for this one. Right. I will give you 2 to 3 minutes. හරි. දන්න ඇති කියලා මං හිතනවා. You need time. Time එක ඕනද කාට හරි? තව. Right. කටිය නිදි එහෙම නෑනේ. ගාන හදන්න නැති කියලා හිතනවා. Right. කාටි කරලා දෙන්නම් කියනවා. Right. Okay. Oh, let's discuss this one. How can I do this one? Okay. Now I will share this screen. Okay. Now the question is like this. This is the question. Draw a fully labeled Born-Haber cycle for the formation of solid bromine chloride, BaCl2, from its elements. Include state symbols for all species involved. So let's try to draw the Born-Haber cycle, but we need to have some idea about the information given as well. Atomization of barium, atomization of chlorine, atomization of barium chloride, formation of barium chloride, ionization enthalpy of barium, first ionization, second ionization enthalpy of barium, lattice formation enthalpy of barium chloride. So these are the information given, right? So having said that, let's try to draw the Born-Haber cycle. So Born-Haber cycle is usually for ionic compounds, right? So in this direction, we will have enthalpy, kilojoules per mole. We need to draw it for the barium chloride. First, we will draw the zero mark. The zero mark should have the standard enthalpies. You know, when the compounds or the elements are in most stable standard conditions, the enthalpy is zero. That is coming from energetics lesson, right? So here, barium solid should be zero enthalpy. Chlorine gas should be zero. Iodine solid is zero. Fluorine gas is zero. Sodium solid is zero. Nitrogen gas N2 gas is zero. So likewise, most stable state enthalpy is equal to zero. And we need to produce barium chloride, right? So that means formation enthalpy of bromine chloride is zero. Sorry, the formation enthalpy of barium chloride we need to find. That is something that we need to found. So it is here, this one, right? Enthalpy of formation of barium chloride, it's a negative value, right? So we will draw this one first in the Born-Haber cycle. These two will add. Actually, you should have a clear understanding what is the formation enthalpy equation. So formation enthalpy equation means the formation products or the produced products should be in the standard conditions, and the reactants also should be in the standard conditions. So barium solid plus chlorine gas, Cl2 gas, is converting into barium chloride solid, right? So it is a negative one. It will be placed around here. So in this direction, value is minus 839, right? 859, sorry. 859. Now, if you look at this one, we are given enthalpy of atomization of barium. Atomization. Atomization means solid converts into barium gas, and atomization of chlorine, and ionization enthalpy of barium second ionization enthalpy of barium and lattice formation enthalpy of barium chloride. Lattice formation enthalpy means production of barium chloride solid from barium 2 plus and Cl minus gas. If I write it down here, lattice enthalpy means barium 2 plus gas plus Cl minus gas 2 times is converting into barium chloride. This is the lattice enthalpy. If you can check these two, this one and this one, they are same. This one I am saying, both are same. So we are producing barium chloride in two ways, right? From barium and chlorine, Ba and Cl2, and from Ba2 plus and Cl minus ions. I am producing these two set, this set from this one. Let's see how to do it. Right? Then I can connect the two ends because both of these are going towards barium chloride. This is how you form the barium, also sorry, Born-Haber cycle, right? So I am trying to produce barium 2 plus from barium solid first. You know, ionization enthalpies are involving in gases. So first of all, I need to convert. Why I need to deal with ionization enthalpies is I need to produce Ba2 plus gas. Ba2 plus gas. So Ba2 plus gas can be produced from Ba plus. Ba plus can be produced from barium gas. Barium gas can be produced from barium solid. I can. Barium 2 plus can be produced from barium plus gas. That is from the second ionization enthalpy. Make barium plus solid. This one can be produced from barium gas because not from barium solid, right? Because barium solid is not the entity involving in the ionization enthalpy. Ionization enthalpy is involving in gases. So barium solid can be converted into barium gas. Barium gas converts into barium plus gas. Barium plus gas converts into barium 2 plus gas. So make a syllabic line, right? One step by step and on, right? Barium gas converts into, first I will be converting them into barium gas. This is the atomization, right? This is atomization of barium. Atomization means solid converts into gases. Cl2 right? Then barium converts into barium plus gas. Positive. Atomization enthalpy, atomization of bromine, sorry, barium, this one. This one. This is first line item. I'm talking about this one. This is a positive one, right? And first ionization, this one. This is also a positive one. Second ionization enthalpy, that is also a positive one. So it is going up. Positive means going up. Negative down, those are going up, right? So this is going up to barium 2 plus. Cl2 වලටම මුකුත් කරේ නැහැ. හරිද? Now let's check, let's put the values here. Atomization. Atomization is 180 plus 180. Plus 180. This is first ionization enthalpy, right? First ionization enthalpy is 503. Second ionization enthalpy is 965. Right? This is 503. This is 965. Then one barium 2 plus other lever. Then I need Cl2. So 2Cl minus ions, right? I'm talking about this one. I need this one. Yellow highlighted one. Then chlorine can be converted into chlorine atomization. It can be atomized, right? Cl2 converts into 2Cl. That is plus one. Then chlorine need to be converted into Cl minus. That is affinity, electron affinity, right? That is electron affinity. So here, now bromine, then after that Ba2 plus converts into 2Cl gas. So this is atomization. මට කවුරු හරි කියන්න බලන්න මේක මේ value එක atomization value එක මේ දීලා තියෙන value එක මෙතන තියෙන කීයද atomization කියලා atomization enthalpy 122 මේක දෙකෙන් වැඩි කරන්න ඕනද නැද්ද? Do I need to multiply this by 2 or not? Yes or no? දෙන්න බලන්න උත්තර. Is this one 2 into 122 or just 122? What's the answer? මොකද හිතන්නේ? Okay. අනිත් කට්ටිය මොකද හිතන්නේ? දෙකෙන් වැඩි කරන්න ඕනද නැද්ද? 122. Atomization enthalpy of chlorine. Yes. It should be multiplied by 2. Why? Because chlorine converts into 2Cl, right? So the atomization is defined as production of one atom. Here it is producing 2 atoms, right? So it should be multiplied by 2. So this should be 2 into 122. So this should be 2 into 122. Then affinity, right? Usually, what do you think? Chlorine affinity, is it negative value or positive value? What do you think? Usually, how about that one? Electron affinity. Electron affinity means Cl converts into Cl minus ions. Is this a positive value or is this a negative value? Positive negative means I'm talking about is it a endothermic reaction? Is it an endothermic reaction or is it an exothermic reaction? This one. කොහොමද ඒක හිතන්නේ? මේ thinking එක මේකට ඕන කරනවා. It is needed, right? So something that I have explained during today's class is needed for this one. Out of these two, chlorine and Cl minus ions, which one is more stable? Cl or Cl minus ions? What do you think? Which one is more stable? Cl or Cl minus ions? Stable is Cl minus, not Cl. Why? Good. Because of the electron configuration. According to the electronic configuration, chlorine is having NS2NP5, right? This fellow is having NS2NP5. This is having NS2NP6. This is stable. So this is going from unstable to stability. This should be exothermic. Stability, it is not absorbing energy, it is releasing energy. So releasing energy means it's an exothermic reaction. Right? So we can deduce that this is an exothermic reaction. Right? So it is coming somewhere around here. So Ba2 plus gas plus 2Cl minus ions. This also need to be multiplied by 2 because we are converting two chlorine atoms into two Cl minus ions, right? So this is x, what we need to find. This should be 2x. Then these two can be used to produce barium chloride all the way down. This is delta H naught L. Lattice enthalpy is given, I think. Lattice enthalpy is minus 256. This is minus 256. මේක බලන්න පුතානේ අර පල්ලට තියෙනවා මයිනස් තියෙන ඊතල උඩට තියෙන ඔක්කොම පොසිටිව් තියෙන. Right? Now how to find x then? Apply Hess cycle to this Born-Haber cycle. Right? How to apply? Starting from 0, you apply Hess cycle or Hess law to this direction. Whatever the things is finding or going to the same direction is positive, and others will be negative. Okay, so let's try to apply the Hess cycle to this Born-Haber cycle by applying Hess cycle to Born-Haber. I will start from 0, going up, 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 and down, and going up again, clockwise. So this one is positive, and the value is also positive. Minimum positive, it is in the arrow is in the same direction that we are moving, right? So it should be plus 180 4line kilojoules per mole. Units because I have mentioned the units here in the graph itself, right? So therefore no need to worry about the units. Then plus 503 plus 965 plus 2 into 122. Then I'm going down. 2x is in the same direction that I'm going. So plus 2x plus minus is the going in the same direction, but it is a minus value. But plus is the same direction that we are moving, and the negative is coming from the value itself, right? So this should be plus negative 2056, and the arrow for and this arrow, this one, this arrow is in the negative direction, or is in the opposite direction that we are moving. So therefore, first it will be negative, and the value is 859. Total will be equal to 0. Right. Now we can do the math and get the answer for x. That is the electron affinity of chlorine, which we have been asked. Right. Any questions on this one? You can copy this down. ප්‍රශ්න දිනන ගන්න ඕනේ. right? So you can get the answer for this one, right? Any questions? I'm not going to do that entropy part. There is some entropy part in that question itself, but I'm not going to do that one. I will take it next week, right? I'll be doing entropy questions, lot of entropy questions next week, right? Okay, if you have done this one, we can conclude the class for today, right? I hope that you have learned something out of this one. Today is the first day, so gradually I will be converting this class into like past paper discussion, and as well as the focused questions, model questions targeting the examination 2026 examination. Just to just to give an introduction how the class will be going. Then anyone can join. This is a free of charge class. This is purely මේක මම තව MCQs හදනවා. These are structured based questions, set of questions. I will be doing MCQ questions as well. Right? So the questions will be discussed. Once we have a fixed set of students, I will be sharing you kind of a tutorial or something like that that we are going to do. We are going to discuss on the Friday nights. Then no need to write the questions, and just we can do the discussion during the class, right? So this is something that I need to do for Kurunagala students for like, I haven't done this one earlier, online classes just for the discussion based one. Just a discussion based one. I couldn't do this one earlier. So this is the first batch, 2026. My pure intention is level up the chemistry marks in Kurunagala. Because Kurunagala chemistry marks and අඩුයි ඒකයි ranks එන්නේ නැති වැඩි. ඉස්සර ranks Kurunagalට දැන් ranks එන්නේ top 10 ranks ගොඩක් අඩු වෙනවා purely because of mainly because of the void in chemistry. Especially in English medium. හරියට කරන්නේ questions කරන්නේ theoretic කරනවා but questions are not done, so students are not prepared for the examination, right? ඒ හින්දා මේක full dumb එක දාලා මම කරනවා මේ class එක, and Tuesday ඔයාලත් මට support එක දෙන්න ඕන. ඔයාලගේ යාළුවන්ටත් කියන්න. ගණන් සෑහෙන හදනවා exam වෙනකම්. ඒක අදාළ නැහැ වෙලාව මොකද්ද කියන එක අදාළ නැහැ. අද මම කලින් ඉවර කරාට මේක සම්පූර්ණයෙන් අපි අදගෙන යනවා class එක. ඔයාලගේ යාළුවන්ටත් කියන්න කාගෙන්වත් හතයක්වත් මම ගන්නෙ නැහැ. ඔයාලා ඇවිල්ලා ඉගෙන ගන්න. මේ කොහොමද ගණන් හදන්නේ, how to do a question, how to take an answer, the equilibrium එහෙම කරාට පස්සේ ගණන් ගොඩ හදන්න ඕන, right? So I know some of you have already done the equilibrium. ඔකට pH ගණන් එහෙම set කරාම හොඳට එනවා. When you are done organic, I know most of you have done organic up to alkyl halides. So තාම අපිට conversions කරන්න බෑ, but I will do the conversions what you can do. Tuesday 9 p.m. the class is purely organic conversions. ඒකටත් ඕන කෙනෙකුට එන්න පුළුවන්. මම link එක share කරනවා. link එක ඔයාලගේ යාළුවන්ටත් share කරන්න. ඒක තනිකරම organic ටික set වුණාට පස්සේ then I will be doing equilibrium questions on Tuesday. Friday mixed exercises, right? Sometimes in some days I will be doing structured, some days I will be doing essay types, and I will be focusing on MCQs as well. MCQ අනිවාර්යෙන් 40ට වැඩියෙන් ගන්න ඕන. අනිවාර්යෙන්. මේකට ප්‍රැක්ටිස් එක දෙන්න ඕන. මම ඔයාලට උපරිම help කරන්න. ඔයාලගේ පැත්තෙන් මට help එක දෙන්න. එතකොට ඔයාලා ඇවිල්ලා ඉගෙන ගන්න free class එකේ. ඉගෙන ගත්තට ඕන ප්‍රශ්නයක් අහගන්න. You can ask any questions, you can clarify anything, you can ask any theory questions as well during the class. You can type in the chat, so we can schedule the class like this. The ඊළඟ class එක තියෙන free class එක තියෙන Tuesday 10 pm. මම time එක හරියට මම communicate කරන්නම්. ගොඩක් වෙලාට 10 pm Tuesday organic conversions. Then other one is Friday 10 pm mixed exercises. මේ වගේ තමයි හැම පාඩමකින්ම හැම කොටසක්ම හැම තියරි කොටසක්ම ටච් වෙන විදිහට මම ගණන් හදනවා. right? ඒතර ඔයාලා ඇවිල්ලා ඉගෙන ගන්න තියරි කොටස් ටික ටච් අප් කරගන්න, පොලිෂ් කරගන්න, මතක් කරගන්න. ලබන සතියේ මම ගොඩක් ඉනෝගනික් එකේ ෆෝකස් කරයි. chemical calculations මම අද ලොකුවට කරේ නෑ. අමාරු ගණන් අපි හදමු. සුපිරි ගණන් තියෙනවා. මේ වගේ ගණන් අපි හදමු. past papers ඔක්කොම මම කරනවා from 2000 to 2025 before you go to the exam. right? So සියලුම ගණන් ටික මම ඔයාලට හදලා දෙන්නම්. ඇවිල්ලා ඉගෙන ගන්න. රෙකෝඩින් එක මම දෙන්නම්. රෙකෝඩින් එකත් යාළුවොත් එක්ක ෂෙයා කරගන්න. එතකොට එයාලට දවස් වෙයි මොන හරි දෙයක් දවස් වෙයි. Okay. So අපි අදට ක්ලාස් එක නතර කරමු. Let's stop the class from here for today. Next Tuesday you can join the class and you can inform your friends as well. So thank you very much. Good night. Thank you. Okay.